Once you have a model, what you can do is prediction. So a model can be used to predict unknown attributes. A simple example is here. We already saw that there is a formula: blood pressure equal to 56 plus age into 0.8 plus weight into 0.14 plus LDL into 0.009. So you have here a formula that relates 4 attributes: blood pressure, age, weight, and LDL. Now what this means is that if you know 3 of these 4 attributes, you can predict the 4th one. So that is what we call as prediction. So when you compute, you can say compute or you can say predict. When you say compute, you are guaranteeing 100% accuracy, that you know this is the formula. When you are predicting, you are mostly approximating. So you have 4 attributes, 4 attributes here. If I know any 3 of them, I can just rewrite this formula to compute whichever attribute I want to. If I know 3 of them, I can predict the 4th one. So this is what you call prediction. Prediction from a model. The above equation can be considered as simple prediction algorithm. It's a simple thing. And relationships can be a lot more complex, leading to more complex models and prediction algorithms. So what you see in that equation is a very simplified model of something really simple. As the problem gets more complex, it will lead to more complex learning, more complex models, and more complex prediction algorithms. So that is what we have been learning is all about. Learning is all about data sets, relationships, modeling, and prediction. So let's talk about what are predictors and outcomes. So whenever we're talking about data in data science, you talk about predictors and outcomes. So what are they? Outcomes are attributes that you want to predict. So whichever attribute you want to predict, they are called outcomes. Like in the earlier formula, we want to predict blood pressure, it is called the outcome. Predictors are attributes that you want to use to predict the outcome. So you have a set of attributes. What you want to predict is the outcome. Everything else that you use to predict the outcome are called predictors. So you might have 10 attributes in your data set. One of them might be your outcome and 3 others might be your predictors. I mean, not all attributes have relationships with the outcome attribute. Only those that have a good relationship with outcome variables will obviously become predictors. So predictors and outcomes, and obviously predictors and outcomes will show some form of relationship, because that's how you can predict outcomes from them, predictors. So learning is all about building models that can be used to predict outcomes, which is the output, using the predictors, which is the input. Here are some examples. We again go back to the same 3 examples. In the case of a customer, the predictors are age, income range, and location, and the outcome can be, is the customer going to buy your product or not? A patient, the predictors can be age, blood pressure, and weight, and the outcome can be, is the patient a diabetic or not? An example of a car might be like the predictors might be use things like cylinder, number of cylinders, and acceleration, and you might want to predict whether the car is going to be a sports car or a family car. So these are what you call as predictors and outcomes. One of the most important things you want to know about is humans versus machines. Humans understand relationships and predict all the time. That happens in a human brain without even we being conscious about it. We keep collecting data, we keep understanding relationships, we keep building models in our heads, and we keep predicting all the time. I mean, anytime you predict, okay, I think this is going to happen. It means that you're using a model that you built inside your head to predict something. You say, I think it may happen. It's a weak model. You say, I'm 100% sure that this is going to happen. It's a very strong model. But human being can only handle finite amount of data, right? But for example, as shopkeepers, you have seen them, they know about their best customers or the long-time customers. They know what their customers like and what their customers want. And whenever a customer comes in, they usually address them by name and they immediately know what these customers want. So even without the customer asking for it, they're going to go pick the item and give it to them. But human being can only handle finite amount of data. So they can know about the preferences of 100 customers. not like 10 million of them. So what happens then? That's when machines or computers come into play, right? We want to store all this 10 million customers information in computers and let the computers learn about the preferences and help you. So machines come into play when the number of entities and the data about them is large or huge, and therein comes machine learning. When you hand it over to your computers to collect all the data, do all the learning, build all the models, and do the prediction, that is where it becomes machine learning. That's when it becomes machine learning, predictive analytics, and data science. So what is data science? Entities, relationships, modeling, and prediction. So what is data science? It's all about picking a problem in a specific domain, understanding the problem domain, the entities and the attributes and the behavior and the events, collecting data sets that represent the entities. You go collect all the data that you need, and then you discover relationships from the data. That is what you call learning. And when computers do this, it's called machine learning. So machine learning is not something out of the world. It is nothing about, it's all about machines learning about certain things or discovering relationships from the data it has. And then build models to represent the relationships. The model can be like a mathematical model. It can be a decision tree model. There can be other types of complex models too. And what we do when we build models is we use past data. When you know about the predictors, we know also the outcomes. So you know the values of the predictors, you know the values of the outcomes, and then using those values establish relationships, and from the relationships you build models. And once you build a model, you can then start predicting. You can start predicting for the current or future data when you know the predictors but you don't know the outcomes. So use the past to learn, to build models, and then you predict the futures when you don't know about the outcomes. Here is an example of what a website shopper would do in the case of data science example. The problem would be to predict if the shopper will buy a smartphone. And what you're going to do about it? You get all the past purchase history of all the shoppers, right? You collect shopper characteristics like age, gender, income level. You collect seasonal information when they do buying, like what kind of things they buy during winter versus summer versus Halloween versus Valentine's Day. You collect all those relevant data that is there. Then you build models. You build models that talk about relationships, about what goes up or what comes down, when the customer buys and when the customer does not buy. So you basically try to relate the other attributes that you know to the outcome. So you look at all the values of the other attributes when the customers are buying versus the values of the attributes when the customers are not buying. So you see that anytime the value of an attribute age is greater than 25, the customer buys. If the value of age is less than 25, the customer does not buy. There comes a relationship. Let's try to use this relationship to build a model. And then you try to predict, which is whenever you see a customer whose age is greater than 25, yeah, this guy is going to buy. That's how you make predictions. So when a new shopper is browsing, predict if the shopper will buy. You use the model and predict in real time whether the customer is going to buy a product or not. And okay, what are you going to do with the prediction now that you know the customer is going to buy or not going to buy? Is you can do some actions like you want to offer chat help. These days, whenever you go to any website, you see that a small pop-up comes up and say, do you want to talk to your live agent? So live agents are costly. They are human beings. You pay them a lot of money. So you only want to offer live agent help to shoppers whom you think are going to buy your product. So you can make an intelligent decision as to which shopper you want to offer a live agent based on this prediction. This is an example of how data science would work for you. Thank you.